Next week, Alibaba is releasing Qwen 3.8 27B, a model small enough to run on your own PC that could get close to Claude Sonnet 5's coding performance. That sounds impossible for 27 billion parameters. Sonnet 5 runs in Anthropic's data centers. Alibaba hasn't even released the weights yet, but this prediction is not coming from nowhere. The previous model, Qwen 3.6 27B, already reached a level that would have sounded impossible only months earlier. It scored 77.2% on Swebench, verified, handled images and video, supported a native 262,000 token context, and brought serious repository-level coding into a dense model that enthusiasts could actually download. Then something even stranger happened. Prism ML rebuilt that same 27 billion parameter model as Bonsai 27B. One version occupied only 3.9 gigabytes, yet retained 89.5% of the original model's average score across 15 benchmarks. The higher quality, 5.9 gigabyte version retained 94.6%. A model that normally requires roughly 54 gigabytes in full precision had been reduced enough to run on an ordinary laptop and even a phone. So the real question is no longer whether strong local coding models are possible. It is this: how close can Qwen 3.8 27B come to Sonnet 5? Who will be able to run it? And could another Bonsai-style release put that intelligence inside almost any device? I'll show you exactly what Alibaba confirmed, what the last model already proved, and where I think this one lands against Sonnet 5. Let us separate what Alibaba has confirmed from what we can reasonably predict, because if the prediction is right, next week could be one of the most important local AI releases of the year. First, the facts. Alibaba officially released Qwen 3.8 Max on August 3rd. It is a 2.4 trillion parameter mixture of experts model, but activates about 95 billion parameters for each token. It supports text, images, and video, and can work with up to 1 million tokens of context. More importantly for local users, Alibaba says the open weights for the 27B model will arrive next week. The announcement identifies Qwen 3.8 27B alongside the Max model, but at the time of this video, its downloadable weights, exact model card, quantizations, and independent local benchmarks are not yet available. That distinction matters. The release window is confirmed. Sonnet 5 level coding is not. Nobody can honestly know its final speed, memory use, or real-world reliability before testing the actual weights. What we do have is a trail of evidence, and that trail begins with Qwen 3.6 27B. Qwen 3.6 27B was not simply a smaller chatbot. Alibaba designed it around agentic coding, front-end workflows, repository-level reasoning, tool use, and the ability to preserve reasoning across a longer development session. The result was a dense 27B model with 77.2% on Swebench, verified, 53.5% on Swebench Pro, and 59.3% on Terminal. Bench 2.0 in the published results. Those numbers did not make it universally better than every Claude model. Benchmarks use different harnesses, prompts, tools, and compute budgets. A percentage copied from two different tables is not automatically a fair comparison, but Qwen 3.6 proved the part that matters. A model in the 27B class could perform useful, multi-file coding and run privately on hardware that individuals can own. It also created an ecosystem almost immediately. Hundreds of adapters, fine-tunes, merges, and quantizations appeared. Developers built coding variants, uncensored variants, language-specific variants, and more efficient formats. And then Bonsai revealed how far that ecosystem could push one open base model. In standard 16-bit form, Qwen 3.6 27B occupies about 54 gigabytes just for its weights. A normal 4-bit build is around 17 to 18 gigabytes. That is manageable on a 24GB GPU, but not on most laptops or phones. Prism ML attacked the weights themselves. Ternary Bonsai represents them mainly with -1, 0, and +1. Its binary version goes further, using -1 and +1 with groupwise scaling. The result is not magic, and it is not lossless. The 3.9GB 1-bit model averaged 76.1 across 15 tests versus 85.07 for full precision. Qwen 3.6 89.5% retention. The 5.9GB ternary model averaged 80.49 or 94.6% retention. Coding remained surprisingly strong, although independent testing found that the smallest Bonsai version could require many more reasoning tokens and still trail the original when both used reasoning. That nuance is important. Bonsai did not turn 4GB into a perfect copy of a 54GB model. It traded some accuracy and computational efficiency for an extraordinary reduction in memory. But the larger implication remains. Once strong open weights exist, the community can take them somewhere. The original laboratory never promised. If Qwen 1000P has a similar architecture and tolerates extreme quantization, a future Bonsai-style version could again bring it below 6GB. That is a forecast, not an announced product, but Qwen 3.6 shows that it is technically plausible. Now for the biggest prediction. I believe Qwen 3.8 27B could land around Sonnet 5 territory for coding, but that sentence needs a very specific meaning. It does not mean the local model will beat Sonnet 5 at every task. Sonnet 5 is a mature hosted system with strong tool use, long horizon behavior, and infrastructure that a raw local model does not automatically inherit. It means the 27B model may approach Sonnet 5 on selected coding benchmarks and short to medium repository tasks, especially when given the right agent harness, enough context, and time to reason. Why make that prediction? Qwen 3.6 already established a 77.2% SWI bench, verified baseline. Qwen 3.8 Max is being positioned around today's frontier models in coding and covert tasks. If part of the Max model's training improvements transfers efficiently into the dense 27B version, a meaningful jump is reasonable. Better data, stronger reinforcement learning, improved tool calling, and more efficient reasoning can matter as much as raw parameter count. But there are two reasons to stay cautious. First, a smaller model may not inherit the flagship's capabilities evenly. It could gain benchmark performance while still failing during long, messy coding sessions. Second, benchmark scores are not the same as product experience. Sonnet 5 may remain more consistent at planning, recovering from mistakes, navigating huge code bases, and knowing when not to change working code. So, Sonnet 5 level is the upper end of my forecast, not a leaked benchmark. My more conservative expectation is a model clearly stronger than Qwen 3.6, competitive with expensive hosted coding assistants on many everyday tasks, but still less reliable in the hardest long-horizon work. Until the files arrive, hardware estimates must be based on a typical dense 27B model. The important number is not only VRAM, it is total memory for weights, context cache, vision components, and the software running around the model. At 4-bit precision, expect roughly 17 to 20 GB for the model before a large context cache. A 24GB card, such as an RTX 3090 or 4090, is therefore the safest single GPU target for a useful context window and good speed. Cards with 16GB, including an RTX 4080 or 5080 class setup, may run a tighter 4-bit build with reduced context, or offload part of the model into system RAM. It should work, but speed and context headroom will be more limited. With 12GB of VRAM, such as an RTX 3060 120GB or 4070 class card, full GPU loading is unlikely at normal 4-bit size. CPU offload can make it run if the machine has at least 32GB of system RAM, but it will not feel like a 24GB GPU. 8GB GPUs should be treated as offload machines, not ideal targets. You may be able to experiment with extreme quantization later, but the unreleased model should not be advertised as an 8GB VRAM model yet. Apple Silicon is different because the CPU and GPU share one memory pool. A 32GB Mac should be the practical entry point for a 4-bit build. A 24GB Mac may run it with a shorter context and little room for other applications. A 16GB MacBook will probably need a smaller than full-bit quantization or a future Bonsai-style build. If that arrives near 4 to 6GB, even base laptops and potentially phones could enter the conversation again. For full precision, forget normal consumer hardware. Weights alone would be around 54GB if the architecture matches a conventional dense 27B model. For most people, full bit or lower is the real local format. The first release will not be the final model most people use. Within days, expect GGUF and MLX conversions, 4-bit builds, speed tests, agent integrations, and community comparisons against Sonnet 5. Then come the experiments, coding fine-tunes, longer context tests, speculative decoding, mixtures with other models, and perhaps a new bonsai release. The most important tests will not be one-shot demos. We need to see whether it can understand a real repository, plan a change, edit several files, run tests, recognize failure, and repair its own mistake. We also need tokens per second, memory use at different contexts, and quality across 4-bit, 3-bit, 2-bit, and any binary or ternary version. A model that technically loads but produces 1 token per second is not the same as a usable local coding assistant. If Qwen 3.8 27B improves the way I expect, it could become the new base model for local coding. If the community compresses it the way it compressed Qwen 3.6, its influence could spread far beyond expensive AI workstations. It could become a private coding agent on a laptop, an offline assistant inside a company, a vision model that understands your screen, or eventually a pocket-sized agent that never sends your code to the cloud. But next week, predictions end and testing begins. Subscribe and turn on notifications, because as soon as the open weights arrive, I will test the real model, coding quality, speed, VRAM, quantizations, and whether it genuinely deserves the comparison to Claude Sonnet 5. The announcement is exciting. The detailed review will tell us whether the local AI world has actually changed.